Uh, Hello, can you see is screen is visible to you, people? Yeah, okay, fine. So it was a bit technical glitch again. So let's start. What I was discussing was like coding mechanisms. So uh, let's save this program as file test.java, like class file test. Now I'm going to perform a encoding to use different encoding mechanisms while reading and writing. So it will lead to an exception. So better what we can say, cached exception. So better I will use throws exception clause in advance. Uh, there is a package in Java called as java.io that we have used in the various last lectures dealing with the file IO. And there is a package called as java.nio, new IO. It stands for the new input and output mechanism. I strongly recommend you people go and check out the package and try to explore more features from this package. Now, while reading and writing the data, we have used binary system or the what we can say byte preferred classes. Like we have used buffered input stream, buffered output stream. We have used data input stream, data output stream, and we have seen file input stream class was used as an argument for the data input stream as well as buffered input stream. Now I will use a character encoding mechanism like a file reader, file writer in the same way buffered reader and buffered writer. So buffered reader is a class which will read data from a file in a character order, character by character. So I will call it as a BR. Now the traditional way of doing it is like use buffered reader and pass the object of new file reader to this class, and in double quotes the name of the file that we want to open. For the, let's say there is a file called as first.java, so I want to open this file. So this is a traditional approach and it works fine. But in the new IO, there is a static class available which stands for files, and it have something called as new buffered reader. Now you can see that new buffered reader was already available in Java, and this is the style that we can use it in the new new IO input output system hierarchy. We have something called as a files, under which there is a class called as new buffered reader. So this is the name of the class itself, right? New buffered reader. So many times I've seen people getting confused between the using a traditional class and using a class from the NIO package. So this is how we can use the NIO package. The second difference is the traditional buffered reader is going to accept to one argument, which is of type file reader, in turn, which is going to accept the name of the file. Whereas this NIO new buffered reader accepts two things. One is a path and the second is character set, right? Char set. So we have to initialize these two things. So let's understand what is this path and what is this char set. Again, both are from NIO package hierarchy. So for that, I will import java.nio.file. So this is another package that I need, and one more, which is import java.nio.char set dot char set. So this is the class that I need, right? So let's initialize a path. So path, it's a static environment, or it's a what we can say. If I have to compare it with the earlier things that we have learned, it's an abstract class. So we can't instantiate this class. So I'll create a variable called as path, and how we can initialize this path variable is again use a abstract class and then call a method called as get path.get mechanism, and in bracket I can pass the name of the file which I want to open. In our case it is first.java. Now what it will do is it will create this, it will convert this string into a path format, path variable format, or the path which is an abstract class. Its instance we are trying to initialize it. It is called as path. So this path.get mechanism will convert the string representation of the file into a path representation of a file. And now I can use this path variable into the program, which we have already used, like path. Now the second thing is, what is character set? Now character set, again a class in Java. So I will create the object as char set itself, and again I'll initialize it as char set dot for name is the method that I'm going to call. And in the char set for name method, there are different encoding mechanisms. So like US ASCII, which is American code, standard code for information in exchange, that is possible. Also, we can pass here in the double quote, instead of US hyphen ASCII, we can also pass UTF-8, can pass UTF-16, then there is UTF-16BE, Big Endian, and also later and on. So a variety of encoding mechanisms supported by this character encoding classes in Java. So right now we are using a standard which is ASCII, right? So we are reading a file which we are expecting to be in the format of ASCII, right? So let's read the file. Now for this, again, I'm going to use a basic class buffered reader. I'm going to call the object as BR. So this is what is the code. So buffered reader, a traditional class reader class, and we are initializing this class with the input stream coming from files.new buffered reader, accepting two arguments, which is path and character set. Now let's try to let's check whether it is working or not. So Java C, the program name is file test. Okay, I guess it's saved in somewhere else. Is it there? File test. Now let's try to compile. Java C file test.java. Okay, path, cannot find symbol path. So let me add import java.nio.file.star instead of this line, and let me just remove this. And now try to compile. Okay. So the path is not found. Git string. Resolve subwork. Yeah, so one typographical mistake that I made was, let me have it clear. So the typographical mistake that I committed is here I have to use the paths. Now it is again a static class from which we are initializing this. We are trying converting the string into the path variable. Now here path is an abstract class, whereas this one is in a static environment, and from which we are using a method called as get, which will convert our absolute path into a, sorry, it's a relative path, into a path variable, which is available in Java. Now let's try to read this. Now BR have one line called as read line. So this BR object, which is a buffered reader class, can access one method called as read line, which will read one line from a file, and it will return null if the file reading fails, or you have reached the end of the file. So what I can do is I can write string message, and let's initialize this message variable to null value, and in the while let's say br.readLine is not equal to is not equal to null. I have to read this variable, this value into a variable first. So I should also write my message is equal to br.readLine, and if it's null, then the while loop will terminate. Now, as there will be some data in the file, this is not going to terminate. Now, what we can do is we can print this message on the screen. So let me write message. Now let's check out whether this reads the first.java file from the disk or not. Now, java c file test.java compiles and java file test. So it is reading the entire file. The main part is now it is not even it is again like because it's a buffered reader, the disk IO is only one. It's not a raw class which is every time you are reading from a file it is going to perform a disk IO. No, whenever we are reading a line, it is reading a line from a buffer and not from the disk. Now, in the same way, we can create a program which can be used for writing the data using particular encoding mechanism, and that data will be written on the disk. Now, see, we have used one encoding mechanism which is called as US ASCII, right? So, the file which is on the disk is compatible with the US ASCII encoding mechanism. What if we use some different encoding mechanism while reading the data from the disk? For example, let me say UTF-8, right? Now let's compile the program again and run it. Java file test. So it works fine. Now what about UTF-16, right? So again, let's clear java c file test.java and java file test. Now here you can see that as soon as I change my mechanism to read 16 bits at a time from a file, the file is perfect. There is no problem with the file. If you open the file with the gedit and use a UTF-8 encoding or a ASCII encoding, you will be able to read the data properly. So here, when we are using a UTF-16 encoding, the terminal of Ubuntu is displaying some information which is not in English, but the actual file contains the information in English. So this is what we were talking since the first lecture. I hope you people are see the output. Can you see the output? Okay, great. So you people are at least listening. Great. So how you can use this? How right now when we are creating we are reading on the disk, we can also pick up a mechanism while writing the data to the disk. For that, there is a parallel class called as buffered writer. Let me call it as BW, and again here I have to say new files dot new buffered writer, and again I have to give path comma char set. Okay. Now let me pick up some different file name. So I will put a comment on my first file name and let me create a new path variable called as path. Paths.get, and let me call it as what should I call it? Let me call it as temp.txt. Now my file will be created called as a temp.txt, and the mechanism that let me use UTF-16 encoding while writing the data to the file. So this is the mechanism that I want to use while writing the data to the file. And in the simple way, what we will do is whatever we are reading from the file, we will write to the file. Control, let me just take this here. So we have what we'll do is as soon as we read from a file, input file, the same data we will write to the output file. So what I can do is BW, which is a buffered writer, dot write a method which can write a string message. So here message, whatever we are reading from the disk, the same thing I'll write into the disk. Let's also write a new line character. So after each write operation, the file pointer will get advanced to the next line. So let me put \n. So this is a simple writing mechanism. Let's compile the program, Java file test. Okay, I've made a mistake. Oh, sorry, the writer. It's a method write, not writer. Writer is a class. So let's compile. Now Java file test. Okay, so it worked. Now let's okay. So why the data was not displayed is, let's call it this one as path1, and here I will use path1. So see what is happening in this program is, you have path variable which is first.java, you have path1 variable which is temp.txt. You are using UTF-16 encoding while dealing with the both files. The buffered reader is opening path, that means it is opening first.java. Buffered writer is opening path1, that means it is opening temp.txt. Whatever we are reading from first.java file is getting written onto the bw.write, means temp.txt. So we are copying first.java value into the temp.txt. So let's compile again, and let's say file test. So now the data has been read, and now something is on the screen. Let's see the content of temp.txt file. Oh, okay. See, there is no data in the temp.txt file. I'm sure that you people figured out why the data is not written. Either I have to say bw.flush in between the program, or make sure that the buffer is closed once the operation is done. So let's recompile the program and run one more time. Now let's check out the contents of temp.txt. Now you can see that the data is present in the file, but there is still some extra information coming, which is fe and into the rectangular brackets, and at the end of the file there are some @ and XOR symbol or symbol, then there is a /, then there is also, and so some extra information is still getting added to the file. So this is how you can pick up the encoding mechanism while dealing with the file. You can also create a different encoding mechanism while reading and writing, but that will create a garbage value. For example, what I can do is I can use this encoding mechanism of ASCII ASCII code for reading the file, and for writing the file I can create a new character set. Let's create it. Char set dot for name is the method, and here I will write UTF-16, that to specific variant, big endian variant, and here while writing the data I will pass it as character set 1. Now this is going to create a real problem. Let me clear the screen. javac file test.java, and now let's run Java file test. Let's see temp.txt. Now the file is horrible. Can you see? Is everyone okay with this one? Did you get this, or shall I repeat some part? Okay, great. You people have understood what has happened. Okay, so see, guys, this is the situation that you people may land in if you are using different encoding mechanisms while reading and writing the data. So what we did is we used one ASCII mechanism file, and we tried to write the same data using a UTF-16 encoding mechanism, which is again using a big endian scheme, and the data is meshed up. Now if you open that temp.txt file, doesn't matter using which editor, doesn't matter whether you are using a notepad or gedit or any other editor, you will get a garbage information. There is no way that you will be able to recover it, because you read the data in a 8-bit format and you tried to write the data into the 16-bit format, and it created a hell, like not possible to read the information now. Fine. So this is from my side regarding the file handling mechanism. I strongly recommend you go and check this NIO package. Although this NIO is not part of syllabus, still I recommend you to use read this. Okay, the recording is on, so I'll be able to upload a video. Fine. Now there is also something called as a random access, and there is a class method called as a random access file, which have a method called as seek, and it will allow you to rotate the pointer wherever you want in the file. So I again recommend go and check that class also, because you people will need these classes while writing the object selection mechanism program. Okay, so this is for the file handling, and immediately we'll start with the next unit, which is creating a graphical user interface. Before starting with the next unit, anyone have a doubt in file handling scenario of file handling unit? If you have any doubt in the exception of the file handling unit, please ask me. From my side, I recommend you to go and read NIO package and also random access class, file random access class. If you anyone have a doubt or question, I will wait for half a minute. Okay, somebody have unmuted. You can ask. Who is this? Okay, you if you don't have any doubt, please post it in the chat box that we can proceed with UI part. Can we proceed with UI part? If it yes, please post yes. Otherwise, I'll wait for no doubt. Great. Good. So let's start with creating a UI. Okay, so I am sure the screen is still visible with you people, and I'll create a new program. Let's call this file as gedit, and let me call it as UI frame.java. Okay. Now, there are two packages in Java using which we can create a UI. One is java.awt package, and the second package is javax.swing. So let's discuss something about this AWT package and swing package. So this AWT stands for Abstract Window Toolkit, and this there is no such long form for swing, but this X stands for extended. Now, what happened is in the early days, people started creating UI for various softwares that people are creating to work for the any of the industry or for any of the company. But what I used to happen is, like right now, I'm using a Debian system, and the look and feel of the code that I'll create, the look and feel of the UI that I create in this Ubuntu system using AWT will be something different, and it will try to match the theme that I'm using in the Debian environment. If you run the same program in Windows environment, then this same program will try to acquire the features created by the Windows theme. So the UI representation of the same software will change depending on the host environment. So people were not happy about this, about the AWT mechanism, and the extended mechanism was available. People created something called as a Java X class, which won't change its depending on the host environment. The representation will be same as it is, and there will be no problem, right? So what we will do is we'll create a frame using AWT, and we'll convert the same frame to a swing format. One important part, like we will do it, and then when we do it, you will understand what I mean. So let me create a AWT frame. AWT, I'll repeat, AWT stands for Abstract Window Toolkit. We are not going to use this mechanism while creating any UI. We are going to make use of swing mechanism. So let me write public class UI frame, and public static main So first thing, I'm not going to create my UI in the class which have a main method, although we can create it, but we will strictly avoid creating the UI using the class which have the main method. As it is the first lecture in which we are discussing the UI, I will use the same class, but I'm not going to recommend this. We will use a different class while creating the UI. Okay, so I want this UI frame class to provide me a frame, right? So there is a class in AWT which is called as frame. So this is a class from AWT. So what happened is UI frame, which is my class, extends the feature from frame, which is the class inside AWT mechanism. Now when I create an object of this UI frame, object is equal to new UI frame. When I do this, actually you are also creating the object of frame class, because your class is inheriting the frame class. Now whenever we create an object, we know that the constructor gets called UI frame. So I will add an empty constructor. Now what we will do is we'll try to compile this program and see whether the frame is created or not. So Java C UI frame.java compiled and UI frame. If I hit enter, the program executes and terminates, and we are not getting any UI. So the reason is the frame is not visible. So what we can do is, this represents the current object. In our case, that means it's obj variable object. So what I can write here is this dot set visible into bracket true. Now the frame becomes visible. Now let me run. Now here you can see that there is icon for Java, and actually the frame is very small here. Let me drag and scale the frame. Now the frame is available. I'll repeat the execution. What I'll do is I'll terminate the program. Okay, and again I'll run the program. See the effect. Something has happened. There is on my status bar of the Debian system, you can see the Java icon had come, and here on the upper left corner, a small frame has been created, right? And it is visible now. Now what we can do is, before setting the frame, before setting the set visible parameter to true, it's a property of the frame, we can use another property called as set size. So these are the properties of the frame, and here I can pass the size to the frame, 99. And now if I recompile the program and run it, now the frame is automatically visible. See, the frame has become available to us. Now remember, right guys, this has to be the last line in your UI creation. If set visible call appears somewhere else in the frame, then you may get some UI representation errors. So we'll see this effect when we'll add more and more components in the UI. Right now there are no components added. So what we can do is we can add one button. So button is a class in AWT environment. Button is a class in AWT environment, which is used to create a button controls, square button controls in the frame. So I've created a variable called as b1 in my UI frame class. Now I'll initialize this variable in my frame. So I'll write b1 is equal to new button, and here I will write button1, which is a label for the button. Now if I compile the program and run, so you can't see the button on the frame, because what happened is we have initialized the button, but that button is not registered with the frame. So mark this word, you have to create a component, and then the component must be registered with the frame. So let's register this component by saying this dot add b1. So this dot add b1 register the component or adds the component to the actual frame. Now if I recompile the program and execute it, you can see that the button is added. Now you can see some plain color appearing on the frame, right? And because of my Ubuntu environment, Ubuntu theme, this button looks like this. If we change this environment to the Windows system, then the button's appearance will again change. Now, another problem is this button have acquired the entire surface of the frame, which is not expected. So there is something called as layout manager. So let me use layout manager. Again, the layout manager is from AWT mechanism, and this layout manager shall be the first line in the frame. This dot set layout, and I'll say new, what I can say, new free layout or a grid layout. Let me say flow layout. Fine. Now compile. Okay. And now you can see that small button has appeared at the top of the frame. You can click on this button and it is even showing that the button is getting clicked. Now what we can do is we can take this same program and execute it in Windows environment, and you will see that this button acquires the representation of the Windows theme. So this created a problem for the programmers, like the theme, or they set the environment, they pinpointedly design the UI, and the UI change its representation depending on the parent or the host environment. So people wanted to create a facility in Java using which they will create a UI which will not change its representation depending on the host. The representation will remain as it is, and there will be not even a single point change in how the button looks. Like look and feel will not change depending on the OS. For that purpose, they come up with something called as swing mechanism. There is a lot of history of AWT and swing. I think you should go and read about it rather than investing time in differentiating the AWT and swing. We are going to do it time to time when we are going to use classes from swing and AWT, sometimes together, sometimes in the boxed environment. So let me write java x dot swing package and put a star symbol which will inherit all the classes from swing. Now I want to change my frame to the swing frame. So what the only change that I need to do is add a J character before the controls that I've created. I've created two controls. One is frame. So I said J frame instead of frame. And I've created a second control called as a button. So here I'll say J button. By adding only these two terms, your frame from AWT is no longer available. The frame is from swing. Another thing, another place where I need to add this J button is J character is here. When I'm initializing the object, this one still belongs to the AWT package. So let me convert it to the swing package. Now let me compile the program and run. Now you can see that the look and feel of the button has changed. And this look and feel will be constant. It is not going to change depending on the host. So this look and feel is from the swing mechanism, and the AWT look and feel mechanism depends on the theme of the operating system or the host environment. Whereas the swing's environment look and feel is not depending on the host. It is not going to change. Doesn't matter you use which system, it will be as it is. Okay, fine. Any doubt till the moment? Okay, another change that you must notice is when I create a frame of J frame or swing, that time this close button suspends the frame, whereas frame, and the frame becomes invisible. The program is still running, so clicking on the close button is not closing the program, it is just suspending the frame. Whereas in the case of AWT, when I clicked on the close button, the frame was not even suspending. So this is another difference between the frame of AWT and frame of swing. So let's add the code using which we can close the frame. So closing the frame, this again it represents the first object called as obj from UI frame. Set default close operation is the method which we can use, and exit on close is the value is what we can say constant that I can use to pass a close signal to my frame when it clicks on the cross button. Now let me save the program and now recompile it. Terminate the program using Control C, recompile. And now if I run the frame, okay, it has a nice button on it. And now if I click on close, observe the terminal here. Now the frame will not suspend, the frame will get closed, terminated. Now the program has terminated. So this is the difference when you add the default close operation. By default, the close operation will suspend the frame or will make it invisible and it will not terminate it. But passing a constant exit on close will make sure that when you click on the cross button, the frame gets terminated. Any doubts till the moment? You can post the doubt in the chat box or I'll continue further. Okay, so we can continue. So now let's get some job done out of this button. Now we have one button on the screen, but when I'm clicking on this button, nothing is happening. So its button is absolutely useless. So let's make this button work. So this something making this button work for us is called as a event handling. Now this is a common wrong answer during the Viva or during the interview. So the question which has been asked many times is when I click on this button, whether the event has been generated or not. And people say that no event is generated. This is the wrong answer. Actually, the event is generated every time you click on the button. It is like our program is not handling the event generated by this button one. So remember, mark this thing. When you people are clicking on this button, whether you handle the event or you don't handle the event, button is generating it. So event is generated. Now we need to process the event or handle the event. So you can prefer the word, whichever word you want, processing the event or handling the event of your choice. Now let me close the program and let's handle the event for button 1. For that, there is an interface in the AWT. Again, I'm using a AWT package. There is an event package in the Swing also, but there is also a event handling mechanism in the AWT package. So I'm going to rely on that. Now, if I use this event package, there is an interface called as action listener. So we know that if it's an interface, your class can implement it. So I will write implements action listener. Now here it's a good example of multiple inheritance. You are inheriting one class and one interface. So this is a multiple inheritance in Java, and we know that Java can do multiple inheritance only with the interfaces, not with the classes. So it is absolutely fine that you inherit one class and the second as interface, and this becomes a multiple inheritance. We also have learned that if you implement an interface, you are forced to develop a method which has been provided by the interface. Now let's see which methods have been provided by this action listener interface. Now I'll try to compile my program. So javac UI frame.java. I guess I haven't saved it. Yeah, you can see there is a star symbol. So it means that I haven't saved the file. Let me save this, and now let me try to compile. So here you can get you can see the error is exchange JFrame implements action listener symbol class action listener. So this is the error. I'm using OpenJDK, so the error is not quite well. If you use SunJDK, you will get a detailed error. Error says that you need to add a method called as action perform. Let me write the method. So I recommend use implement action listener call and then try to compile the program, and the compiler will give you that you need to implement a method called as action perform. So even if you forget the method name, no worries, because when you implement an interface, you are forced to implement a method which are declared inside the interface, right? So action performed is a method which is declared by interface action listener. So when I say implements action listener, it is a binding on my program to implement the method called as action perform. Now this method accepts the argument of type action event, which is a class. Now if I try to compile my program will compile. Okay, I've made a spelling mistake. Okay, STENER. What is said? UI frame extends. Cannot find. Oh, sorry. Action lies. Let me put a comment on this. I'm sure now I'll get an error. It was a spelling mistake. I thought this is a compiler giving a warning of. Let me compile this. Yeah, now you can see that it says that UI frame is not abstract and does not override an abstract method called as action perform, which is accepting an argument of type action event. Okay, fine. So it was a spelling mistake, not a OpenJDK kind of stuff. Let me put a method, and now let me try to compile the program. Yeah, so it works. Now still, it's a blank method. It is doing nothing. So still, even if I run this program and click on the button, we haven't defined what action we want to do. So here is the relation. The button generates an event. This button needs to pass this event to the action perform method, right? So the code that needs to be added is b1 dot add action listener. Again, I'll use this keyword. See, this is the common confusion point for the students. So let's understand what this code means. b1 is a button which is generating an event. There must be a facility which will handle this event. Now we are saying that b1, and there is a method called as add action listener. This method of button class will register button with one of the event handling mechanism. Now in this program, who is providing the event handling mechanism? The class UI frame. UI frame class is providing the event handling mechanism by saying implements action listener and adding a method called as action perform. That means UI frame class is doing two jobs. One is creating a frame and providing an action and event handling mechanism. What button is saying is, button says that button is getting created and it registers itself, the button register itself with the event handling mechanism by saying this. Now what do you mean by this? UI frame obj new frame triggers the call to the constructor. So inside this constructor, this keyword represents object obj. So b1.addActionListener, this means object obj. And who this object is? Object is of UI frame. And what does UI frame does? UI frame does JFrame and action listener. So UI frame have both capabilities of creating UI as well as providing action event handling mechanism, right? And on the next line, we are saying this dot add b1. Is it clear or any confusion? Okay, spelling listener. I just saw the chat box. I got a spelling of listener. Are we? Do you got what I said, or there is some confusion? Do you get really what I mean by saying add action listener into bracket this, or do I need to explain it again? Yes, Aditya said is clear. Please explain again, Mandar. Okay, fine. So bear with me again. I am in the Debian environment, so I have some limitations in creating a nice UI. So I'll use PowerPoint representation. It is, it is taking a bit more time. Okay, open. So let's say this is the button that we have created on the frame. Now, who is creating a frame? Let's say there is an object. Let's say this is the object which is creating both frame. This object is creating a frame. Now to use a different color. So this object is creating a frame, as well as the same object is creating a event handling mechanism. Oh, the same object is creating an event handling mechanism, right? And this is your constructor. You are in the constructor, or this is the button which is inside a constructor. So what code we are writing is, we are saying b1 new button. So the button object got initialized, right? On the next line, we are saying v1 dot add action listener. So this button is generating event. Button is generating the event and it is throwing in air. So button has created an event and it is throwing this event in the air, and there is nobody to listen to the event. It is right, like take example that right now I'm teaching on the WebEx and I don't know whether you are listening or not. So but still I am throwing the voice and I am not sure whether there is somebody to listen to the my voice or not. The same way, this button is generating an event and throwing it out. Now, it is not the responsibility of the button that somebody must catch this and perform an action on it. But what button can do is, button can say, right now button is broadcasting this. Instead of that, what button can say that, hey, please, this is what I am saying, and now listen to this. So what button has done, instead of just passing the message in the air, button sends the message particularly to one listener. Now this listener is here, b1 dot add action listener. And now I have said this. This means the object of the frame. So this is the object of the frame. And who is implementing the action listener method? The class implements action listener. It is the same class is also implementing the frame. So when I created an object of uFrame class, when I created an object of this uFrame class, this object had both frame as well as action listener. So the object, blue box, blue square rectangle represents the object, and this object have UI of frame as well as action listening mechanism, right? And button wants to register to the action listener mechanism. So how this button can refer to the object in the constructor? We want to refer to this object, right? And we are inside a constructor. So we know that when the object is in process of creation, we can refer to that particular object by using this keyword, right? So to register, this button wants to register with the action listener mechanism. So this mechanism is available with the keyword this. The query, it is Mandar, I guess. Mandar, did you get it? What I want to say? Great. So still what has happened is, now the button have registered itself with the action listener, and action listener is going to catch the event generated by the button. But we haven't defined what action you want to do when action listener mechanism gets the event. So let's add the action that we want to perform. So when the event gets generated, the action listener this catches the event and it passes that action event to the action performed method. Now in this method, I will write the call system.out.println, and let me put a message called as this is button 1. Now we are printing the message on the terminal. Let's see whether it works or not. Let me open up a terminal. Let me compile the program. Let me run the program. So here is the program, and let me click on button 1. Now here you can see, observe here on the terminal. When I click on the button, you can see that the message is appearing on the terminal. So now the event handling has been done. Event handling mechanism is done. What if you have two buttons on the frame? Let's add one more button, B2, and let's initialize. Let me copy the code and paste it here, and just replace this B1 character with B2. B2 new frame. Let me call this label as B2, and B2 dot add action listener. This dot B2 dot add, and now okay, let's terminate the program. Let's recompile. Let's run. Now we have two buttons, but if I click on button 1 or button 2, you are getting the same message. This is wrong. If I click on button 1, I should get button 1 message. If I click on button 2, I should get button 2 message. Let's learn how to do it. So there are two ways. We will explore first approach of doing it, and we will explore the second approach in the next lecture. So let me say string cmd and a dot get action command. So what this does is, get action command returns the string of the control. Now when B1 is getting clicked, this a dot get action command returns the button 1 label. When button 2 gets clicked, this a dot action command will return button 2 label. Now what we can do is, once we have the label inside string message, we can compare it. If command dot equals, if command dot equals to button 1, then print the message, print this message. Else we can print the second message. In the else, I will press the line here, instead of button 1, I will say button 2. So let's recompile. Button 1 clicked, this is button, so we are getting the message. Now let's click on button 2. Now you can see that button 2 message has appeared. So now the event handling mechanism can execute the task depending on which button is clicked. So this is all for the today's session. In the next session, we are going to continue with the UI. The new assignment will appear on the Moodle today itself, based on the file handling and object serialization. If you have a doubt, please ask the doubt in the chat box. Else we will quit the session. Okay, see you in the next session. You can leave the meeting.